Hello everyone, I welcome you all again on this lecture series on transportation engineering. This is lecture number 18. This lecture is about your traffic control sections. In last lecture we were talking about intersections. Intersections, the locations where two or more roads intersect with each other. Now, when there is intersection, there is possibility of collision. We have already seen the type of conflict points which generates during a intersection. To remove these conflict points, we may provide at grade intersection, the intersection which is provided at the same level when the roads are meeting at same level, or grade separated intersection. We have seen grade separated intersections like overpass, underpass, like your clover leaves, like trumpet interchanges, diamond interchanges, etc. While designing a intersection at grade, means at the same level, we have to control the motion of vehicle, because at the same level the conflict points are more. So in order to control, we can channelize the vehicles using your rotary or channelizing islands. The rotary we have already studied. If we have less traffic, the rotaries are provided for a traffic value more than 500 vehicles per hour. So if we have traffic less than that, or we don't have enough space to provide a rotary, we intend to provide a signalized intersection. Signalized intersection means where the movement of traffic is regulated with the help of traffic lights. Today in this lecture we are going to talk about the signalized intersections, the design of traffic signals, and how these signals can be useful for allowing the traffic volume without any conflict. Let us start with this lecture. Traffic signals, you all have seen these signals on road. You already know what these color means. So this is an arrangement which is made on intersection in order to allow a safe traffic movement through intersection. It is a regulated traffic movement. Active control arrangement in which the driver has to follow certain instructions, willingly or not willingly. Like in rotaries, we do not give right to driver, we just provide channelizing so that driver can move in the way we provide the design. But here the driver will have to actively participate in this regulation. Like if he see a red sign, he has to stop. If there is green, he should start moving in order to clear off the intersection. So these are the signs and symbols which we see on the road. There are lights present on these signals. This is a traffic signal. The red light is a stop sign. Whenever you see a red light on the road, you intend to stop, or there is no traffic movement from this stream whenever there is a red light. Then you will find a green light. Whenever you are allowed to move through the intersection, you will see a green light. The end of green light is denoted by a yellow light. This yellow light is also known as amber light. The yellow light is also known as amber light. And amber light indicates the end of your green time, or it indicates the start of your stop duration or red time. So these lights are present on each section of the intersection, each leg of the intersection. Now let us go through some of the definition which will help us to design these traffic lights, traffic signals. We want to design these traffic signal in terms of time. What time should be allowed for a red signal? what time should be allowed for green signal, because there is certain traffic volume which is moving through the section, and we should allow all of the traffic to clear off without any collision or without any conflict. So to provide this kind of arrangement, we should know the timings here on the traffic signals. So let us talk about some definitions. First one is cycle length. Cycle is a process of blinking from one color to another color and then coming back to same color. Like when we are starting with green light, just after a red, a green duration starts. This is green light. The end of green light is denoted by a amber duration or yellow duration. Let's call it A. And then finally we have a red duration. Now after this red duration, we will again have a green duration. This will be a green duration, and before this green duration there was a red duration. So the time from start of one green to the start of another green, this time is known as cycle length, and this event is known as a cycle. When green turns to amber, then turns to red, and then again it is intended to turn to green. So this complete green, yellow, red, green. So this is a cycle, and the time duration is known as cycle length. Then we have some intervals between these cycle lengths. First interval is change interval. Change interval is nothing but it is the yellow time. The time duration or the interval which denotes the change from green to red. This is an indicator or a warning for the drivers that the time is going to change or your motion is going to cease. The green duration tells you about to leave the intersection, but the red duration tells you about to stop before the intersection. So the yellow duration will tell you about that your movement is about to cease. Whenever you are going through a section, this, let us say this is an intersection. So the yellow duration, there is this light pole present here. So there will be two conditions. One, that this light is green and it just turned yellow. Now you are coming from this direction. This signal should be visible to you from a distance, that if it is yellow, you are able to stop your vehicle before entering into the intersection. If it is yellow, you should not enter to the intersection. So this distance, let us call this distance, should be equals to SS, stopping sight distance, because after looking at this intersection, the distance provided on the road should be enough to stop your vehicle. So this is SSD. What is this? This space here after your SSD, after your start of vehicle, this is your width of opposite lane, and this is the zone where you should be when your red signal starts. Whenever your red signal starts, either be in your limits or cross the opposite road, completely cross the intersection. So the scenario allows us to design the yellow time in such a way that if I am in this zone SSD W, and your vehicle which is completely entered or completely cross the intersection, means your complete length of vehicle L has crossed the intersection. If you are in this zone anywhere, you should be able to cross your intersection. If you are here somewhere, if you are here, you should be able to cross. If you are here, you should be able to cross. If you are here, you should be able to completely cross your intersection. So the maximum time which should be allowed in change interval should be your side distance plus your width of opposite lane. Let us call this lane A and this lane as B. So width of lane B plus the length of the vehicle. So this distance should be covered during that yellow duration. Divide by the speed of the vehicle. Our speed, let us assume these values are given in meter. So velocity is taken as meter per second. So you have a time, that is amber time in seconds. So this time should be available for the driver, so that if he is not able to stop, because this is SSD, if he is just enter the SSD, he will not be able to stop before the intersection. So let him cross the intersection. That's why we provide this yellow time, so that he can cross this much distance. This is the time. There may be another scenario when your vehicle is well behind the SSD, means your vehicle is not in this zone. So this second case, when your vehicle is not in this zone, this is your first case. When your vehicle is in this zone, this is your second case, when the vehicle is not in this zone. So the time provided for the vehicle should be equals to, in seconds, should be equals to the reaction time and then the stopping distance. The reaction time and the stopping time, braking time. So we can call it as the reaction plus the distance or the time which it takes to stop itself before the intersection. The time will be its initial velocity or the velocity v divided by its deceleration. Its velocity v divided by its deceleration. So you can calculate this value using your friction and gravity. You know the relation of deceleration. F is equals to a by g. Now you can replace a with fg and you can create this relationship. So these are the two simple cases with help of which your yellow time is designed. Yellow time, the time which allows you to identify the stop duration, or which allows you to identify when your go duration is going to end or your stop duration is going to start. This duration is designed on the two bases. One, whenever you are in a danger zone. Danger zone is when your distance from the signal is less than SSD. If your distance from the signal is less than SSD, you will be provided enough time in order to cross the road. But your distance is more than SSD, it is intended that you stop before the intersection. So this is your change interval. Next one is clearance interval. What is clearance? Whenever your waiting time or your yellow time finishes, your red time starts. At that point, if there is any vehicle on the intersection, it is very dangerous for the vehicle which are coming from other direction after their green light. Let us say I am going from this direction. After my yellow, I am at the point of intersection. I am between the intersection, and that time, because of yellow from another direction, other vehicles are coming. I have not cleared off from the intersection, but other vehicles are coming. So during this condition, there are chances of conflict. So in order to keep the intersection safer, we provide a duration which is known as all red duration. This is all red duration. All red means all the signals will be red. This duration is provided in order to clear off the intersection if there is any vehicle present after the green cycle of one direction. So each and every cycle has this all red duration. All red duration when all the signals are red. All the signals means signals for all the direction are red. So these are the two interval. One is change interval, that is yellow time. Clearance interval, that is all red time. If you see this diagram, you can denote this period as all red. This is red for you, but also this is red for other directions. This red vehicle, red duration will allow you to clear off from the intersection. We generally don't observe this because whenever we are at the intersection, we only look at our traffic lights. When the traffic light turns from yellow to red, it is visible to us that it has turned from red to yellow. But for opposite lanes, this scenario, that as our light turned from yellow to red, it will take some fraction of seconds for their light to turn from red to green. So that duration for all the intersections will be, because if it is red for me, it will be green for some only one intersection. So for that intersection, this duration which is available, this will be fraction of red seconds, and then it will turn to green. So you can assume this red interval and interchange interval as the interval between this red and green times. What are phases? We are talking about the movement of vehicles on the road. It is an arrangement in which only certain traffic movement is allowed, which can pass through the intersection easily without any conflict. A phase system is a combination of various phase movement to allow all the vehicles to clear off the intersection systematically. Let us see one phase system, sorry, two phase system. If this is an intersection, let us say this is an intersection, there will be traffic coming from this direction and it will intend to move in this and in this direction. Similarly, traffic is coming from this direction, it will intend to move in this and in this direction, it also. Similarly, from here we have traffic. If we allow all this traffic to move simultaneously, this will be known as single phase, one phase system. Then if we design the system in such a way that in two goes we allow the vehicles to move, like when there is less right turning traffic, left turning traffic is always allowed. If this is, here we have less right turning traffic, so we can allow the vehicles, and here we have less right turning traffic. If right turning traffic is less, we can provide this single phase, phase 1, and this phase 2, in which we will allow vehicles to So this is possible only when the right turning traffic is not significant. If it is significant, then there will be collisions. If it is not significant, then we can allow these vehicles to move. So this is phase 1 and this is phase 2. This is road A and road B. So once we are allowing the vehicles from road A to move, and then we are allowing vehicles from road B from both the direction to move. This is two-phase system. Then we can see this four-phase system when there is significant right turning traffic. This is generally seen the roads we can allow the straight traffic and the right turning traffic at the same time from one lane, then straight traffic and then right turning traffic. Now this is right turning traffic, then straight traffic, right turning traffic, then straight traffic, and we have the right turning traffic. So this is phase 1, phase 2, phase 3, phase 4, then again we will move on to phase 1. So this is how all the directions are cleared off from the intersections. First this will be allowed, then they will be allowed, then they will be allowed, and then this traffic volume will be allowed to clear off. So this is the phase arrangement. There can be two-phase system, there can be four-phase system, there can be six-phase system. So phases are based on the traffic volume and the type of traffic movement. If we have significant movement of right turning traffic, we cannot provide two-phase system. So this is what phase is in terms of your traffic intersections. Lost time. Lost means the time which cannot be utilized. Utilized, what we are doing here, we are crossing the intersection. So the time which is lost while we are crossing the intersection, that we have not utilized. We have two types of lost time. One is your startup lost time. Whenever there is an intersection in which we just saw a red light turning green, there are lines of vehicle present here and so on. When the red light turns to green, it takes some time for the first passenger to react, or the first driver to react to the situation. So there is some time lost. Let us say we have 40 seconds of green duration. The driver is active, but when he observes that red turn to green, he react, and this reaction takes some time. Similarly, the second vehicle also will react, third vehicle driver will also react, but their reaction will be overlapped with the, if we draw graph between headways and your number of vehicle. So the first headway means time between crossing the section. Let us start the timer and note when the first vehicle leaves the section, then when second vehicle leaves the section, then when third vehicle leaves the section. So we will find that the first vehicle, after the starting of your green window, leaves at certain time. Let us call this at time point t. This is for your vehicle 1. Then vehicle 2 will take little bit less time as compared to the first vehicle. Vehicle 3 will take comparatively lesser time. Vehicle 4 again less, but further these vehicle will take same time, means after first vehicle the second vehicle is moving, the time duration or the time gap between these two vehicles, it is the time headway. So when the flow starts, a proper flow starts, there is no delay. So all the vehicles will take same time to cross the sections. This is your time taken by the vehicles which are behind after the start of the move. This, the equal time which is taken by the vehicle, is known as your time headway. The time which is required between the two vehicles at a certain speed, at a flow value. But these values are E1, E2, E3 and so on. These are your extra time which you have lost, which you can utilize for the traffic intersection. So this is the summation of EIs for I equals to 1 to n, what is the nth vehicle is taking. So this is the total lost time. Total lost time, total startup lost time, the time lost during the starting procedure. Another one is clearance lost time. Clearance means the duration which is provided to you, the amber time and your clearance interval. These are the two clearance intervals provided to you. Amber time, so that you can clear off the intersection. All red time, if there is any vehicle on the intersection, can clear off. So if we do not utilize, if the traffic do not utilize that time to move through the intersection, that is also known as your clearance loss. So this is also considered as clearance loss time, but it is very small. It is very small. So we actually focus on this startup loss time. This we can observe also, the startup loss time. So the clearance loss time and startup loss time combines to form total lost time, and this is equals to your startup lost time plus clearance lost time. This depends on your phases also. Now the time when we are moving through the intersection is your green time. The yellow time is also provided you to move through the intersection. Yellow time is end of green time, not start. In yellow time your red light has not started, so you can utilize that yellow time if you are in that zone you talked about, the SSD zone. You can utilize that time to cross the intersection. So your green time, your effective green time, let's call it GI, is actually your green time plus your amber time. The green and the amber duration both are used to clear off the intersection, minus your lost time, because the time which you have not used for clearing of the intersection will not be your green time. So your effective green time is your green time plus amber time minus your lost time. What is green ratio? Green ratio is the ratio of your green time to the total cycle time. If we say cycle time is C naught, so the green ratio is equals to your green interval into, means out of total duration of green, how much green time one phase has. What is cycle duration? Cycle duration is, let us say if it is a two-phase system, so cycle duration will be green of A, amber of A plus red of A. Is it so? This is the cycle duration. During the time of red of A, the other lane is moving. So we can write red of A as green of B plus amber of B. So this is, let us say, G effective for A plus G effective for B. If we say, if we want to calculate the actual volume passing through the section in your effective time I, so this is the total time which is allowed in the section. From A direction, the proportion of green time is given for this proportion of green time, that is G I by G. This cycle time, you can write it as GIA plus GIB into your traffic volume or traffic capacity of this. This is your actual traffic flow capacity, or you can from the intersection. From one direction, these many vehicles will move in your green time. So these are the some definition which we will use in order to design the traffic signals. Traffic signal design is done by these four methods. One is trial cycle method, in which trials are taken by assuming your cycle time. This method is based on your traffic flow. Another one is approximate method. This approximate method is based on your pedestrian speed. We allow a pedestrian to move from an intersection. During that time, the vehicle should be stopped. So that duration is taken as the red time for that phase. So this concept is used to design your traffic in approximate method. Then we have your Webster method. Webster method is a sophisticated design approach. Next is IRC method. IRC method uses two methods, approximate method, Webster method. Approximate method is used to calculate the value of cycle time and then green time. Webster method is used for checking if the time is enough or not, and then one check is applicable provided by IRC to check whether the time duration or the cycle time calculated by approximate method is enough or not. So let us start with the trial cycle method. Trial cycle method. Trial means number of assumptions are taken. Some assumptions or values which are given, which will be given, are flow value or peak flow from phase A and phase B. Let us say peak flow, 50-minute count from phase. It can be a 1 hour count, it can be a 1 day count, but we need a peak flow value. So peak flow can be for a very short duration. So let us take for 15 minutes. This is, let us say, 200 vehicle, and we have for B we have 150. So the traffic flow passing through section A is 200 vehicle in the peak duration, and from B direction it is 150 vehicle. What else we have? We have amber time is already conveyed, that we have amber time of 3 seconds here, 2 seconds here. This is designed from the previous calculation which we have done during clearest interval, based on your width of road, based on your braking and reaction time. So this is your amber duration. Then we are provided with your headway. This is your time headway. For both the lanes, time headway is 2.5 seconds. So these values are provided to you, and using these values we can calculate the time of cycle, if it is enough or not. But initially we should assume, for step 1, assume cycle length C naught between 40 to 60 seconds. So let us say it is 45, or let us say 50 seconds. Assume it as 50 seconds. Now what we know that in 15 minutes around 200 vehicle from A direction and 150 vehicle from B direction crosses the section. So this traffic flow should be maintained while we design a intersection or signalized intersection. In order to allow, let us check how many vehicles, because we are having this value in seconds, so let us check how many vehicles passes through this section per second. So for in 1 second from intersection A, or from direction A, we have these many vehicles, and from intersection B we have these many vehicles. Let's calculate the number. This is 0.22 vehicle per second from direction A, and we have 0.167 vehicle per second from direction B. We have taken the cycle duration as 50 seconds. So we have to allow how many vehicles in 50 seconds to maintain this flow? .33 vehicles 3 seconds. There 11 vehicles in 50 seconds. So if we allow 11 vehicles during the 50 second of cycle time, it is satisfactory, because this will maintain the flow as it is already required in peak duration. So this is 11 vehicles for 50 seconds. If so, green time for A should be 11 vehicles are moving with a headway or the time headway of 2.5. Green time for this should be 2.75 seconds. Green time for B should be 8.33 multiplied by headway. This is equals to 20.825 seconds. We have amber time for A as 3 seconds. We have amber time for B as 2 seconds. So let us calculate the cycle time which comes out from this calculation. Cycle time is amber time at A green time B plus amber time at B. This is 825. Let's sum it up. So it is, the required time is 53.325 seconds. Now let us take another assumption or another cycle, another trial with 55 seconds and calculate the same values again, and we will reach to a value. We will do this trial till the assumed value is not equal to our calculated value. Till the assumed value is not equal to our calculated value. And this assumed value should be nearest multiple of 5, like 5, 50, 55, 45. So this way you can take the assumptions and you can do the trials. This is the trial cycle method. The next method which we are going to study is approximate method. Look, these values will not be asked in GATE examinations because these complete numericals are very lengthy and they will not be asked in GATE examination because they don't want you to design a traffic signal in GATE examination. But some things out of these will be asked, like on what parameter does your trial cycle method depends. So you can say that on the maximum or the peak flow value at the intersection, the trial cycle method depends on. So you should know the trial cycle method depends on the peak flow value. Next method what we are going to see is approximate method. Approximate method when there is an intersection, let us call the width of this road as WB and call the width of this road as WA. We have pedestrians which are allowed to cross the road. If they are crossing the road, the vehicular traffic from that direction should be stopped. So while your pedestrians are moving, that should be the red time for your vehicular movement from that direction. Let us say our vehicle are moving in this direction. Now I have pedestrian movement from here, here. My pedestrian will start moving and will take certain time to cross this section. What time will be taken? The time taken by the pedestrian will be equals to the width of the section divided by the average speed. Generally, a healthy pedestrian walks with the speed of 5 kmph or 6 kmph. To accommodate the unhealthy or the aged or the slow walkers, the value which is taken for pedestrian design is 1.2 meter per second. 1.2 meter per second. This comes around 4.5 or less than 5. So this value is taken as speed of pedestrian. So the time taken by the pedestrian to cross section at road A is width of road A divided by 1.2 meter per second, the time in seconds. Similarly, the time taken by the pedestrian to cross section at road B will be width of road B divided by 1.2 meter per second. In this process, we allow some time to the pedestrian to reach the zebra crossing. Let us say we are allowing the pedestrian to move or to cross the section from this point. So we will allow some time so that if a pedestrian is some distance away from this starting point of crossing, then he can move and then he can cross the section. So we provide 7 seconds of time to reach the cross section, and then the time which is calculated here to cross the cross section. This time duration is the red time for your traffic movement at A. So stop time, or we can call it pedestrian green time, P, green time P for A direction is width of this section 1.2 plus your 7 seconds. Similarly, GPB will be equals to width of B plus 7 seconds. This is actually equals to, if we are allowing the pedestrian to move from the section A, means the vehicle will be stopped at section A, means this is the stopping time or the red time for section A. I'm sorry, this is section A. Similarly, this is red time for section B. We know the cycle time is equals to green time of A plus amber time of A plus red time of B. Red time of A. The green time of A and amber time of A collectively is equals to the red time of B. Whenever I am moving through the section in my green time and amber time, the phase B will be stopped. So I can write it as cycle duration is RA plus RB. And I know what is RA plus RB. This is WA by 1.2 plus 7 plus WB by 1.2 plus 7. So this is your cycle duration. This is your cycle duration. In this cycle duration, this time is your green time of B plus amber time of B, and this is your green time of A plus amber time of A. Now you know the amber time values from your initial calculations. You have your green times which is written here. Okay, let's listen this calculation. Right. So green time of A will be width of B plus 7 seconds minus amber time of A. Okay, this is your green time of A. What is your green time of B? Is width of section A plus 7 seconds additional given minus amber time of B. You have green times for your sections, but does this time enough to allow the traffic volume which is there on the road? To check this, let us check the ratio calculated from GA by GB from calculated here and equate it with the traffic flow, like traffic flow in A direction by traffic flow in B direction. If this ratio is okay, we have no problem. But if the ratio is not equal, we should fix one value and find the another value of time. Fix one value from here, from the calculated values, fix one value because these values are known. We can fix means we can use one value out of GA or GB and calculate the other value in order to accommodate the traffic volume in this section. So we will take the value of minor road. We will take the value of minor road from this calculation, whichever is. If GA is minor road, we will take the value green time GA from here. If GB is your minor road or the B is your minor road, we will take your green time from here. I am taking, let us say B is your minor road. So we will say B time is enough for the traffic of that minor road to clear off. Now let us calculate the time required for the major road, that is GA, to clear off the section. So GA will be your QA by QB. These are known values multiplied by another known value from the calculation, that is GB. Now this value is enough for the vehicle to clear off from this direction also, because the ratio was not equal. If it was equal, we have no problem. To make it equal or enough for the vehicles to clear off, we have to calculate this GA. Now this new GA, let's call it G-A. If it is major road, then this is your actual green time or new green time. So what we have the final calculation of GA dash GB. We know the amber time of A, we know the amber time of B, so we have complete calculation of your cycle length. This is your approximate method. Approximate method tell us about that the pedestrian movement and the volume of the section is used in order to calculate your cycle length. The next method, which is also given in your GATE syllabus, that is Webster method. Webster method. This method is given in your GATE syllabus. So we will discuss this method extensively and we'll do one question also. What this method says, this method gives you a formula for cycle length, that is 1.5 L plus 5 1 by y. Let us see one by one what are these terms. Your L is lost time, and this is given by Tn into n plus r. Tn, it is your start lost time, n are number of phases, like you have phase system, two-phase system, four-phase system. So these are number of phases, and R is your all red time. All red time will be given to you in the question. We have starting lost time. This is assumed to be as 2 seconds. So the L formula comes out to be 2n plus R. Then what is y? Y is actually the proportion of vehicle traveling in both direction. The proportion is corresponding, it is the sum of proportion of vehicle traveling in both the phases, and this proportion is in terms of your calculated value, or the design period, the duration in which you are designing, to the saturated flow. So this y is equals to ya plus yb. Here ya equals to qa by sa and capital S. Yb is equal to qa by s qb by sb. What is qa and qb? Flow during design period, means if we are designing this section for certain duration of the day. I am designing this section for morning 8 to 9. So what is the flow during that period is qa. The flow of vehicle through the section from a direction, this is qa. What is sa? This is saturated flow, the maximum possible flow from this direction. Similarly, qb and sb are same as above for another direction. This is ya and yb are the proportionals of traffic flow at that duration. Then we can calculate the value of green time at a section as what we have duration, cycle time is c naught, we have lost time as L. So this is the duration which we can use for traffic to flow. This is the total duration of cycle length. This is L, the lost time. So remaining will be the total duration of time which can be used for the traffic flow from the section. Can be from any direction. And what time the direction A will take is equals to the proportion of vehicle from traffic A divided by the total vehicle. Similarly, the green time from B will be yb divided by y, the proportion of traffic moving from B out of this remaining time. This is your green time. Oh, I'm sorry. Green time for section and section. You have your amber times, or you can calculate amber time from cycle time itself. Let us see one question. You are given qa. This is the design flow from this section as 400 vehicle or 400 PSU per hour. Similarly, the design flow or design duration flow from section B is 250 PSU per hour. The saturated flow from this section is 1200 vehicle or 1200 PSU per hour. Saturated flow from this side is 1000 PSU per hour. This is a two-phase system, as we have two phases. So two-phase system. The R duration is all red time. This is given as 12 seconds for each cycle. So what we have here, we can calculate y value as ya plus ya plus yb. What is ya? Ya is 400 by 1200. This is equals to, this is saturated flow, means maximum So this is 1 by 3, or I can write it as 0.33. YB is 250 by 1000. This is equals to 1 by 4, or I can write it as 0.25. Y is 0.33 plus 0.25, and write it as 0.57. We can calculate the value of L. L is equals to, if it is a two-phase system, so 2 cross 2 plus 12. This is equals to 16 seconds. Now using the Webster formula, cycle time can be calculated as 1.5 L plus 5 divided by 1 minus Y. Let us put the values and calculate the answer. Cycle time is coming out to be 67.44 seconds. Let us calculate the green time for direction A. Green time for direction A is the proportion of traffic moving from direction A divided by the total value and the cycle time minus the lost time. The value is YA is 0.33. This is out of 0.57. This is the total cycle time minus the lost time is 16. The value which comes out to be 29.87 seconds, and GB will be similarly the proportion of traffic in the YB direction. This is equals to 0.25 by 0.57. This is equals to 22.56 seconds. So this is how you can design your section, and this method is really important for a GATE examination. You can be asked for calculating the cycle time only. You can be asked to calculate the directions or directional green time. So go through this topic again, and we will solve some more questions in your question solving sessions from this method. The last method which we are going to discuss now is IRC method. IRC method. IRC method is a combination of your approximate method, because in step 1 you calculate your cycle time using your approximate method. So approximate method, we know it uses the pedestrian traffic, and we want to allow the slowest walker to cross the road. So approximate method use this pedestrian traffic and your volumetric traffic passing through the road. This is how we calculate the cycle time from approximate method. We have already discussed this method. So you can calculate cycle time from this method, and in step 2 you can check for each road check by IRC method. So what check it applies? The check given by IRC is the cycle time or the green time for any direction should be equals to 6 seconds plus x. X means number of vehicles passing through that section, let us say A, minus 1 into 2. What this check is, let us discuss. Whenever we are at an intersection, we have vehicle 1, vehicle 2, vehicle 3 moving out of the section. So we want X number of vehicle to move out. But the first vehicle will take 6 seconds to cross this section. So first vehicle takes 6 seconds to cross this section. Remaining X minus 1 vehicle will move and take time equal to headway. This is 2 is your time headway while crossing your section. 2 is your time headway. So this is the total duration required for XA vehicle to move out of this section. So this is your green time for section A. Similarly, green time for section B is 6 seconds for first vehicle, plus for remaining XB minus 1 vehicle you can take 2 seconds for each vehicle. Now the time calculated using approximate A or B using approximate method should not be less than IRC GAB values. इन दोनों से कम नहीं होना चाहिए. The value of green time from approximate method should not be less than the values of this green time calculated by IISc method. If this check is okay, another check is applied, that is from Webster method. Traffic volume is calculated from Webster method for given GA and GBs and checked for saturated flow values. Means another check is applied using your Webster method. So there can be a question in GATE examination. What are the two methods which IRC method employs to calculate your green time? So you should know the approximate method and the Webster methods are two which IRC method will use to calculate your green time. This is all about your signal design. You should remember Webster method, complete formula, complete calculation. From approximate method, you should know it is based on your pedestrian volume and your traffic volume. Your tricycle method is based on your sectional traffic volume, and your IRC method is based on your approximate and Webster method. So basic concepts should be known. Exact calculation will not be asked in your GATE examination like for tricycle method, for approximate method from IRC method, but Webster method, the complete calculation should be practiced many times in order to take a feel. If there is any question with any variation comes, you should be able to solve this question. So we will stop the lecture here only. In next class, we will discuss the different signalized arrangement or relation between successive signals, which allows us to clear off a certain road section with continuous motion. We will discuss this in next lecture, and we'll talk about various signs, markings on road, and remaining things from traffic engineering. Thank you so much.